Here we are looking at a hanging picture problem. We are told to find tension 1 and tension 2. We are given that the angle of the chain on the right is 15 degrees and that the angle of the chain on the left is 78 degrees. We are also given that the picture is hanging is 20 kilograms. When first tackling this problem, you want to look at this box right here. It allows us to fill in our equations later. It tells us that T1x equals T1 cosine 15, T2x equals T2 cosine 78, T1y equals T1 sine 15, T2y equals T2 sine 15. Now let's look at our horizontal motion. We know that the forces that go minus the forces that slow equals mass times acceleration. We know that the picture is not moving, so acceleration is 0, and thus ma equals 0. Now let's look at these arrows over here. They tell us that forces that are going up and that are going to the right are go forces. Thus, forces that are going down and going to the left are slow forces. So that relates to horizontal forces, because T1x is now considered a go force since it is going to the right. T2x is considered a slow force because it is pointing to the left. So T1x minus T2x equals 0. Thus T1x equals T2x. Now we come back to this box. This tells us that T1x equals T1 cosine 15 and that T2x equals T2 cosine 78. So that means that T1 cosine 15 equals T2 cosine 78. The cosine of 15 is 0.966 and the cosine of 78 is 0.208. So T1 0.966 equals T2 0.208. Now we can look at vertical motion. As with horizontal motion, the forces that go minus the forces that slow equals ma. Also like horizontal motion, ma equals 0 because the picture is not moving, so acceleration is 0. In this case, though, both T1y and T2y are go forces. This is because that in the hanging picture problem they are both going up, which is a go force. So the thing that is slowing down these go forces is the weight. The weight in this case is found in this box, that weight equals mass times gravity. Mass is 20, so weight equals 20 times 9.8, which is gravity. So weight is 196 newtons. So T1y plus T2y, the go forces, minus weight equals 0. So T1y plus T2y equals weight. And we found weight over here, so looking at this box as well, T1 sine 15 plus T2 sine 78 equals 196. And I found the sine of 15 and sine of 78 because we know that T1y equals T1 sine 15 and T2y equals T2 sine 78. And the sine of 15 is 0.259 and the sine of 78 is 0.978. So T1 0.259 equals T2 0.978. I'm sorry, plus T2, that's a typo right there. And that equals 196. Now we have to use substitution to find both the tensions. This equation right here is taken directly from the vertical motion equation right here. The only difference is that there is 0.208 right here. The 0.208 was taken from right here when T1 0.966 equals T2 times 0.208. Since that is true, in order to find T2, we can use this value right here and put it in for T1. So 0.259 times 0.208 plus T2 times 0.978 equals 196, the weight again. Again, this was taken from this equation, plugging 0.208 into T1. So just doing algebra, we eventually get that T2 equals 200.35 at 78 degrees. This makes finding tension 1 a little bit easier. So, we take the equation T1.966 equals 200.35 times 0.208. This is taken from this equation. But now that we know T2 is 200.35, we can fill it in under the previous unknown T2 spot in this equation. So once again, T1 times 0.966 equals 200.35 times 0.208. And just going through algebraic steps, we get that T1 equals 43.14 at 15 degrees. And I believe, yes, that is the end of the problem. Bye, Miss Taylor.